Hi, welcome to my presentation called The Limits of Imagination, an open source journey. Basically, this is about my open source journey and projects in natural language processing over the years, starting from 2018 till 2025, basically 7 years of work. All of these projects are open source. My name is Aroma Rodrigues. This is a little bit about me. This is my bio. I'm a Python enthusiast. I've been coding since 2014. It'll be a decade next year. I'm a multi-PyCon speaker, so I've spoken at PyCon US, Estonia, Lithuania, Hong Kong, Sweden, EuroPython, Ohio, PyCon South Africa, India, and also had a project being presented at Fourth Asia. I've been on the natural language processing train since 2018. I do fun experiments, sometimes with data, Python, and language models, because I believe, as do most multinational companies now, that the human condition is encoded in language, just as science and math, and it's inevitable that one day we will be able to use computers to help us linguistically as they do mathematically. I've been using this bio since 2019, and it has come true, basically. So these are some of the stories that I'm going to be sharing with you. I'm going to be sharing 10 stories with you. The first one is from PyCon India 2018. It's a terms and conditions summarizer. The second one is PyCon South Africa in 2019. It's an NLP fake news detector. The third one is PyCon US 2024. It's called Only Bad Demos in the Building. The first one is PyCon India 2018, Terms and Conditions Summarizer. So terms and conditions, everyone knows terms and conditions. And it's all very clunky, not great to go through, but you basically just have to do it. I personally have not gone through a lot of terms and conditions except a couple of rental agreements. And for this project specifically, I think I went through a terms and conditions document by PayPal, if I remember right. We are always drowning in unreadable legal language across emails, apps, and websites. What I was trying to do is I was trying to build an NLP pipeline to extract obligations, permissions, and risks from terms and conditions documents. Basically, what I wanted to do was when I was going through a document that was full of terms and conditions, I wanted to see the risks associated in the terms and conditions document. The risk had to be highlighted in red, basically. It would have empowered users to skim legal agreements with context and not confusion. If the line would be a risk, it would basically be highlighted. My problem with this particular project was that there was no existing data set. And I had to hand annotate a bunch of sentences as obligation, permission, or risk. So I built a label data set from scratch using first principles of contract structure. The outcome was an NLP pipeline to extract obligations, risks, and user rights from legal documents. Because there was no usable data set, I could only annotate, I want to say, around 2,000 sentences, which was not a good amount to sort of train a good classifier. But I created an SNLI style data set from scratch using first principles. And what you could do today to improve accuracy is basically to use some of those sentences to one-shot train an LLM, which is a large language model. Or you could use an LLM, which is a large language model, to create synthetic data of around 10,000 sentences to train a more powerful classifier, basically. This project basically came from my work at Fidelity Investments. We were working on a bunch of 401k accounts. And what happened at that time was there's supposed to be a lot of rules that are supposed to be applied on all of the accounts data. And what happens is you have legal documents that are these rules, and then you have a query mapped in a language that computers can understand. But there's no mapping between these two. So because I was working with natural language at that time, I was like, we could maybe create our own rule processor of sorts. The second one is from PyCon US 2024. It's called Only Bad Demos in the Building. I was spending a lot of time at home during this week called Fix Hackler at work, where they just let you do whatever you want. And I had a couple of existential questions that I wanted answers to. For example, will forensic portrait artists keep their jobs? Can AI write my tableau better than me? Can I build a clueless trial? Fashion matcher? How do I generate clean, non-duplicate synthetic data? So basically what happened was I was waiting at home for my H-1B visa, and I was not in contact with my colleagues. They were 12 hours away from me. So I could not collaborate with them for this week. I went through an existential crisis. I got into a little bit of stoicism, looked up a lot of philosophy, and that's why I had all of these philosophical questions basically. So, who gets to keep their jobs in this post AI world? Will forensic portrait makers keep their jobs or not? So, what happened was, we were going through a lot of large language models being released in the world, and everyone had this existential crisis of whether they were going to keep their jobs or not. And because I'm also an artist on the side, though I don't draw a lot of portraits, I was like, what's a good job to get into if they do take away my software engineering job? And I was like, what is AI not good at? What is AI not good at? And the answers were like, oh, maybe images, but they have to be like very specific images. And when do you need very specific images? So the answer that came to me was forensic portrait makers, basically. And what I did was I went on to Kaggle. I found this data set of character actors. What happens with character actors is they are like they're very descriptive, right? You're always introduced to a character actor as, oh, he was like a particularly looking man. He had a certain kind of a nose, very bushy eyebrows, maybe like a spot on the top of his lip, etc., etc. So the first one is a picture of the actor, and all of the rest of those pictures they're created by AI. So it's a man with a curly hair, dark eyes, small nose, and thin lips wearing glasses. And there is a couple of like other descriptors basically. And this is basically what AI created. I do think this is a particularly hard example, simply because the first one, if you see the structure of his like upper lip, it's like a certain structure that's like difficult to explain unless you like gesture with like your fingers or something. So the AI didn't get it right. So I want to say the third picture. Here's a couple of like other examples. This wasn't a very good example either. It didn't get it right. And it also put on a lot of like facial hair or something. This is another example with a blonde character with dark eyes and a side smile and fringe. His eyes are dark and small and his lips are thin. His upper teeth are visible. He's smiling and he seems excited. None of them actually resemble the original actor. So basically, my conclusion was that, oh, maybe forensic portrait painters will keep their job. And then what happened is I put in this example. I really like this example because this is the perfect example of what I would just say a really nicely descriptive character actor looks like. And what happens because of this specific sort of description is AI almost gets it right. You should see these examples, especially the first generated image. It's like very similar. It's very similar to the face of the actor itself. These are from, I want to say, Bing Creator. These are from DreamWorks. And both of them did really well. I want to say, even the bottom left over here looks like the character actor. What did I do then? I thought about what would I do if they took away like my job? What would I do? So I have a couple of dream projects that I would spend a lot of time on. And one of my dream project was to write my own travelogue. But I had a lot of logistical issues. Like, for instance, I took 300 pictures of a day out in Chennai. So what I wanted to do was I wanted to make AI do it basically. So I wanted to write my own travelogue. And basically what I tried to do is I just tried to use a lot of AI models to write my travelogue for me. I had a lot of photos that I plugged into from my drive, used a captioner. And I would just say it did pretty well actually. Some of the captions, like what a child would say about an image. For instance, this one says, my prompt was on her day out in Chennai, Aroma saw. And it's all very simplistic. It's, oh, I saw through a window. It doesn't say a lot about the image or anything descriptive, but it was factual. It was a caption. The second image, it's on her day out in Chennai, Aroma saw, I saw this beautiful flower. On her day out in Chennai, Aroma saw, she spotted a car driving down the street. Now, the issue with that is that if you check out images on Instagram, you'll see an image posted like the one with the car and like all of those like colorful buildings of sorts. And it wouldn't look like, oh, she spotted a car driving down the street. It would be something like, oh, there were like a lot of colorful buildings lining the street. That is what like an artist would say, or someone who was using Instagram would say. But AI basically decided to concentrate on cars simply because of like how it had been trained. On her day out in Chennai, Aroma saw the plums of the Frania trees were it basically gave me like the descriptors, but it didn't do a really good job with adding poetry into the captions basically. I was like, there's some work to do, but it'll probably just write my child up for me. And then I just basically gave up and watched a movie. And the movie that I watched was Clueless. And there's this scene where it lets you like match dresses and lets the dress be fit onto your body so that you can see what you look like on that given day. And I was like, well, that sounds absurd, but can AI do it? Because we can't do it anymore. So I went to Kaggle again and I looked up like a data set that had a lot of images of tops, bottoms, dresses, etc., etc. And I plugged it into this collab notebook of sorts. And what I tried to do is I tried to superimpose it on the photograph of a model wearing a completely different dress of sorts by finding out the boundaries of the dress that they were wearing, like the top or the bottom. And I tried to repair it using AI. And let's see what AI basically did. So this is what the original image sort of looked like. And if you look at repaired images, I would just say the third and the fourth one look slightly normal. Everything else looks off, but the third and the fourth ones look slightly normal. A long way to go, but we're basically on the right path. The third one is from PyCon South Africa in 2019, which was a natural language processing fake news detector. So the goal was to trace who's being blamed in misinformation, not just flag what's fake. The data set was real WhatsApp forwards, informal, noisy, multilingual. My method was combine SciPy in NLTK based event models with POS tagging and dependency parsing with a lot of like minimal training data required basically. Because these were parsers, these were not trainers, these were not classifiers. The improvement is today LLMs will offer richer context, better understanding of blame dynamics, and scalable solutions. So, impact of fake news. BuzzFeed, there were like 22 million interactions on the top 50 fake stories. This is from 2018. Knight Foundation, 10 million plus tweets from 700K plus accounts linked to fake conspiracy news. Routers, which is in India, 52% get news from WhatsApp. Rumor fueled violence had led to deaths. This was around the time when WhatsApp forwards would basically get you lynched back home in India. So, techniques for detection, keyword extraction and verification. So, basically, I used Rake and LCK for extracting key phrases. I used a news API. Google had a news API back then to cross check real coverage of keyword based claims. I used reverse image search for detecting photoshopped images. There was a lot of content verification, so I compared articles from spoof sites versus mainstream media. I used a lot of fact checking platforms such as Alt News or hoax layers. And for textual clues, we use grammar and spelling mistakes, overtly positive or negative sentiment, the sources or suspicious sources, and repetition of certain words. Some other techniques that were used, and this is way before we had like really good classifiers on sentences, before bots basically. So all of these things are normal parsers and they use NLTK from Stanford. Syntactic patterns, POS tagging statements to detect, blame assignments, praise, even causality, active passive voice patterning using NLTK, entity and emotion tracking, tracking named politicians, detecting associated emotions that are fear, hatred, sympathy. My basic goal over here was to actually detect propaganda. The reason I wanted to detect propaganda was because sometimes the news stories are like, oh, X happened. And sometimes it's X happened because of Y. So they're basically trying to blame Y for whatever happened, whatever happened. So there is like in literature, there's a thing called the path model of blame. Who did what and why? in literature, like in languages, they basically have a certain language model to identify if the structural features of that particular sentence would actually lead to someone to blame. So there were like causative verbs basically ordered, cause, claimed. There was some sort of thresholding, like the percentage of sentences that showed propaganda structure in that text. So this is an example of how the parser basically worked. This is a sentence, and we're just putting in like a pattern. Now, these patterns at that time, because this is a parser, right? So you would have to write your own pattern based on your understanding of language and whatever is present in that text. And after parsing it, you would find out if it's followed the path model of blame model or not. So these are some of the other stories that I'm going to share with you. The one in PyCon Estonia in 2023 is called If Your Friends Are Bullshitting Using LLMs. The other ones were presented at EuroPython in 2022, PyCon Hong Kong in 2021, PyCon Sweden in 2021, which was if how we are conditioned to believe the news is polarized. The other one was presented at PyOhio in 2020. It was analyzing bias in children's educational materials. The one in PyCon Estonia in 2023 is called If Your Friends Are Bullshitting Using SNLI. SNLI is one of my favorite data sets, specifically because of like entailment, contradiction, and neutral sentiment analysis. Basically, because I think it models a lot of things that we will need to use in the future, basically. For instance, even when you're giving like an instruction to an LLM, you need to make sure that it understands if it's a contradiction, if it's an entailment, or if it's like neutral in comparison to like the instruction it was given before. So the goal was to use natural language processing to spot contradictions in statements, proving when your friends are being inconsistent. This project actually it did actually come from a lot of bullshit that I heard from my friends. For instance, they were like, oh, we're like 15 minutes away. And then they wouldn't show up for the next 30 minutes or something. That's where this project really came from. So it was a real life scenario. The models that I used at that time were to compare using BERT and GPT-2 embeddings for detecting contradiction. My data set was to leverage SNLI for building and training contradiction models. The impact was to improve LLM coherency, tackle hallucinations, and filter fake or contradictory news. So this is like some of the slides that are presented in this presentation. It's like 6 ways to hone your bullshit detector at work. We're like surrounded by bullshit all the time. It would be really nice to give someone else the job to detect bullshit. It's just like thinking through bullshit all the time. There's a couple of articles that go like how to detect bullshit, even on sites like LinkedIn. So it is actually a real problem. It's not just a personal problem. It would also be, I want to say, a professional problem. Or how to measure someone's bullshit. And it seems to be for someone on the spectrum, for people on the spectrum. So I guess like people on the spectrum needs a bullshit detector more than someone else needs it. So there are 3 classifications for bullshitting using SNLI. The first one is entailment, the second one is contradiction, and the third one is neutrality. Now, these things mean exactly what they say. So entailment means that there's 2 sentences that basically say almost the same thing. They like support each other. Contradiction is like when they contradict each other, and neutrality is like when they don't know anything or they don't have anything to do with each other. For instance, Jim rides a bike to school every morning, and the second one is Jim can ride a bike. I would say these are like lightly entailed because they don't contradict each other and they're not too neutral with respect to each other. They do actually have some source of information with respect to both of them. So this is an example from the paper that was published using SNLI. The premise is a dog jumping for a frisbee in the snow. The example one is an animal is outside in the cold weather playing with a plastic toy, which is an entailment. An animal, a dog, is outside in the cold weather in the snow, playing with a plastic toy. A plastic toy is a frisbee, so it's an entailment. The example two is a cat washed his face and whiskers with his front paw. Now, the animal is a dog, so clearly it's not a cat. and they're like washing their face and whiskers with their front paw. So it's like contradicting what is being said in the first sentence, which says clearly that it's a dog jumping for a frisbee in the snow. The third example is a pet is enjoying a game of fetch with his owner. This is sort of neutral because it could, I want to say, entail, or it could be a contradiction, or it could be like not related to the first sentence at all. I want to say precisely, if you wanted to use very precise language, I would say the actual sentence that would be a direct contradiction of the premise is a dog is like a dog, and you'd have to name the dog. A dog is eating a bone inside the house, and you would have to basically make sure that it's the same dog that we're speaking about as in the first sentence. SNLI is a collection of 570K human written English sentence pairs manually labeled for balanced classifications with labels entailment, contradiction, and neutral. We aim for it to serve both as a benchmark for evaluating representational systems for text, especially including those induced by representation learning methods, as well as research for developing NLP models of any kind. These are like examples from SNLI. There's text, judgments, and hypothesis. And everything in the judgment column is basically the label. So this was basically my pipeline. This watch on the screen is basically the pipeline that I use to find out if my friends were bullshitting using SNL. It's a data set. We use a tokenizer. We convert like all of our sentences into tokens, and we put them into a model, and we get like pre-trained embeddings out of it. And then we put it into a new model for training. Basically, what we're doing at like the second step is we are trying to use whatever information has already been learned by a certain model. For instance, in this case, it's BERT or GPT-2. And we're extracting a form of that sentence that has all of that information from like the context space of BERT or GPT-2, which is why what we get out is a pre-trained embedding. There's a sentence, and the end product is basically a pre-trained embedding, which has the semantic or like the meaningful understanding of that particular sentence in the context of everything that has been learned by a model such as BERT or GPT-2. So into this new model, we're basically putting in all of our old training as well. So it gets to use its old training as well as gets to do some sort of like new magic on top of it. And the last one was the inference box, basically. Some details about the BERT model. The BERT model was proposed in BERT, pre-training of deep bidirectional transformers for language understanding by Jacob Devlin, Ming-Wei Chang, Canton Lee, and Christina Tutanova. It's a bidirectional transformer pre-trained using a combination of masked language modeling objective and the next sentence prediction on a large corpus comprising the Toronto Book Corpus and Wikipedia. The abstract from the paper is the following. We introduced a new language representation model called BERT, which stands for Bidirectional Encoder Representations from Transformers. Unlike recent language representation models, BERT is designed to pre-train deep bidirectional representations from unlabeled text by jointly conditioning on both left and right context in all layers. As a result, the pre-trained BERT model can be fine-tuned with just one additional output layer to create a state-of-the-art models for a wide range of tasks, such as question answering and language inference, without substantial task-specific architecture modifications. BERT is conceptually simple and empirically powerful. It obtains new state-of-the-art results on 11 natural language processing tasks, including pushing the glue score to 80.5%. This is all really old. Yeah, we don't really need BERT today, but this is an old project. I say it's a very old project. It's just, I want to say 2 years old or 3 years old. But that's basically how massive the jump has been from BERT to what we do today using GPT. So this is like from the open source documentation associated with BERT. The OpenAI GPT model was proposed in language models are unsupervised multitask learners by Alec Radford, Jeffrey Wu, Rivon Charles, David Luan, Dario Modai, and Ilya Sutskever from OpenAI. So this is a large transformer-based language model with 1.5 billion parameters too. And it's trained on a data set of 8 million web pages. All right. So this is like a page from its open source sort of documentation. These are the two language models that I use basically. And this is a diagram for you to understand what happens when we get pre-trained embeddings from a certain model. So this is the semantic space. This is like meaningful space. What it basically means is this certain word, a certain distance from the x-axis, meaningful x-axis. We don't know what the meaningful x-axis means, but the model knows. And the meaningful y-axis and the meaningful z-axis, basically. And these are like all of the distances between those two words. And those are like the semantic distances between those two words. It basically says the meaning of this particular word is different from the meaning of this particular word by so and so distance. These are basically what I did. I just trained BERT and GPT-2 embeddings. This is another example of it's two headlines from two different editions of news. The first one says Bernie Sanders scored victories for years via legislative side doors. And the second one says via legislative side doors, Bernie Sanders won modest victories, right? The first one makes it seem like the victories were really grand. And the second one makes it seem like the victories were very modest. So someone who's reading the first edition would think that it was like a great thing. It would be praise. The second edition, it would make it seem like it was not praise. It was not such a great thing. So this would basically slightly contradict each other, right? So these are like some of the labels. I do not remember. I think label two is contradiction. And you can see like how the scores are like higher for the first and the last sentence and like slightly lower for the second sentence. Maybe it just feels like modest victories and victories is not that different. Maybe it's if we basically said that Bernie Sanders lost, it would say that it's contradictory on large scale. But it does say that it is contradictory, though lightly. So this is another project that I presented at EuroPython 2022, PyCon Hong Kong 2021, and PyCon Sweden in 2021. It was to analyze sentiments in news headlines to examine bias, comparing it to public perception from surveys. The initial approaches basically failed to capture the complexity of the sentiments and the bias in headlines. The revised approach, it leveraged advanced NLP techniques to better align sentiment with real-world reader biases. The outcome was the failure led to deeper understanding of contextual sentiment, analysis, and bias measurement, essential for interpreting media influence. So my next project was at BioHio 2020. It was analyzing bias in children's educational materials. This was specifically gender bias, such as portraying female characters predominantly as mothers and housewives, while male characters were seen as breadwinners. I used NLP techniques. This was way before birth, or maybe birth had just come out. So I was using a lot of parser structures and rudimentary NLP techniques, using mostly NLTK. We can analyze representation bias by tracking the frequency of gender terms, identify stereotypes through adjective associations, and detect victim blaming language in text. For instance, in some countries, the proportion of female characters in mathematics textbooks was found to be as low as 30%. To combat these biases, it's crucial to revise curriculum to promote gender equality, update textbooks to be more inclusive, and use NLP tools to continually monitor and correct those biases in educational content. So some of these techniques are really easy. It's just basically counting a lot of pronouns, making sure your entities are mapped really well to their genders, and counting how many people of that particular gender are present. And because of like rudimentary techniques, you were able to like POS tag a lot of adjectives. So you could associate adjectives with the entities in that particular sentence and be able to deduce like the sentiment of that adjective. You would not need a lot of, I want to say, high tech NLP techniques. You would only need maybe a dictionary and a scorer of sorts. So my research focus was examining how gender bias in children's educational materials shapes perceptions and roles. For example, female characters predominantly portrayed as housewives, while male characters are shown as breadwinners. My key findings were there was a representation bias. So female characters were underrepresented in fields like mathematics. So a lot of the people doing the math used to be men. So like it would be Tom bought 12 watermelons and never like Daisy bought 12 watermelons. There was also stereotype bias. For instance, a doctor was usually male and a nurse was usually female. There was also sort of culture of blame. So a lot of like victim blaming languages, maybe using passive language as opposed to active language, like she was raped instead of someone raped her. So we did a lot of like analysis on techniques for bias detection, representation analysis using token frequency index, stereotype evaluation using adjective and role association, using SPACY and LTK, plain language detection via path model of blame, identifying causality, and labeling bias. The change that I came out from this study was to revise the curriculum to reflect gender equality and to remove these stereotypes. So, some of the other stories that I'm going to share with you are one of it is from PyCon Lithuania, again in 2023. It's about chatting with ChatGPT about everything and nothing at all. It was when ChatGPT first came out, and most of my talk is basically based out of my free time explorations with ChatGPT. It started out as like a fun experiment. I used to even post on social media about, oh, this is what I asked ChatGPT and this is what it said back to me. A lot of like jailbreaking and all of that. And I decided to make a whole study out of it, basically. My next story is about AI in software development. So it's about experimenting with SVMs and why SVMs are really important. And my ninth story is about shoes for the visually impaired. This was a project that was presented at FOSS Asia in 2016. So PyCon Lithuania 2023, chatting with ChatGPT about everything and nothing at all. So it was like an overview of ChatGPT's rise and the question of whether it was true AGI or not. There was an explanation of the training process for LLMs, including data usage and model architecture. I subjected it to the WIT test because at that point, ChatGPT was like trained on a lot of data that was present on Reddit. So it was not very good with WIT. So I decided to test like what it feels or like what it understands through like various riddles. And I also use like riddles from like specific languages like Hindi or like some other sort of like cultural nuanced riddles to see how it would perform. And like complex context and nuanced language basically. It had at that point it had issues with verbal math problems and concepts of understanding Venn diagrams. So if you would give a kid a problem statement to solve using a Venn diagram, they would be able to solve it easily if they were, I want to say, in grade 8 to ChatGPT at that time. Also, sensory experience gaps. So, highlighting the model's inability to process real world sensory experiences, such as hearing an egg crack, because it didn't know what happened after you heard an egg crack, because it didn't have the sensors to sense any of those things. Also, metaphorical language and relationships. Oh, at that time in 2023, ChatGPT was not really good at metaphorical language and comparing it to human performance. Basically, to answer the question of whether ChatGPT is AGI. My answer to that today, actually, is that in certain ways, ChatGPT is better than humans. So it is, I want to say AGI plus, and at some things it's not. So it's in those areas, it's not AGI. So some of the questions that I basically asked ChatGPT was, when is a door no longer a door? So the answer it gave me was very logical, but because this is a riddle, it's a riddle, right? So it's like a door is no longer a door when it no longer serves the purpose of providing an entrance or exit to a room or building, or when it is unable to be opened or closed. Logical answer. Logical answer. But then I reminded it that we were solving riddles. So it had to be like in a fun mood of sorts, basically. So I was like, this is a riddle, answer it. When is a door no longer a door? And then it's grabbed the answer from somewhere and it's like training data or something. It was like, a door is no longer a door when it's ajar, which is basically what the answer was. So it was like way witty. The second question was, what tastes better than it smells? And because it had like previous context of, oh, we were in like riddle mode, it knew that something that sounded absurd like that was a riddle. And it told me back, this is a riddle. The answer is tongue because it tastes food but doesn't have a smell. What building has the most stories? It detected that this was a riddle. It said the answer is library because it has many stories. It was right. It got a bunch of them right after I told it that we were like in riddle mode. So maybe it had to access like some sort of like training memory that was associated with riddle and like witty, I want to say, language. And I guess it got like some sort of an answer, which is probably, I don't know, it could be right. Does a staircase have a bottom at the top? I don't know. But the real answer was supposed to be legs. And it did give an explanation that could, in some contexts, be the right explanation. So it did really well on creative tasks. I asked it like a bunch of questions again around sensory experiences as well. It didn't have really good answers for it at that time. So my next presentation is about experimenting with SVMs. This was presented at AI and Software Development Summit in 2024. The reasons we like SVMs. I like SVMs. Or like data scientists like SVMs. It's called support vector clustering. It's a clustering technique using SVM principles for unsupervised learning. It maps data to high-dimensional Hilbert space versus a kernel tree. It finds minimum enclosing sphere and then maps boundaries back to the original sphere. It uses Gaussian kernel, which is a nonlinear transformation. It has two key hyperparameters. Q stands for kernel width, controls cluster granularity. P, which is a soft margin, controls tolerance to outliers. And it does not assume shape or the number of clusters. It basically adapts naturally. So, kernel width is basically the size of the circle inside which you would want your points to be placed to say that, oh, this is the space that is similar than all of the others. And PS, it's like this soft margin between two peaks. If there are two peaks, there could be points that lie in both of like those circles of sorts. So you want to make sure that those between points lie in like circle one or circle two, either of those circles, right? Which is a factor that we call P. And these are like the hyperparameters that are trained to get that data. So SVMs basically handle non-convex overlapping noisy data. They have better accuracy than traditional clustering on complex data sets. For example, Iris is like a very, I want to say, famous data set. That data set, like data scientists like to talk about. It's an elegant blend of theory and practical clustering power. The reason I really like SVMs, and this is like an example that I give everyone, is that say you have a line which is only an x-axis, right? And it has, I want to say, on the screen 14. Those have to be 14 dots. So you can see that clearly there's 7 green balls and then there's 7 red balls. And you're able to draw like a line in between and you're able to say that these are like two different clusters of data basically. But what happens if the data is mixed like on the line, on the third line basically? It's like mix of like red and green balls. So you can't really go in and draw a line through the x-axis to say that this is the separation between these two clusters. Now what happens is, and this is basically the principle of SVMs, we introduce a different dimension. We take all of our data into this different dimension, basically a y-axis, and we separate it out. For instance, if all of the red colored balls go to the positive y-axis and all of the green colored balls come to the negative y-axis, we can just separate out the data by saying that the separator is the x-axis. So this is basically what SVMs do, and this was my presentation at AI and Software Development Summit in 2024. The next project I want to talk about is the one that I presented at FOSS Asia in 2016, which was Shoes for the Visually Impaired. My purpose was to improve daily mobility and confidence for the visually impaired. They were just shoes with some basic ultrasound sensors. And what they wanted to do was they wanted to sense an obstruction either in front of them, behind them, or at the sides. It was supposed to improve mobility for visually impaired. So instead of using like an ultrasound stick, they would be able to get feedback using those ultrasound sensors. The control unit was Arduino, and it had a Bluetooth module which transmitted sensor data into an Android device. The Android app at that time was built using MIT App Inventor and PhoneGap. So our vision was to like maybe move to a MATLAB based prototype at that time because this was back in 2016 and maybe change like the feedback because at that time it was like really clunky and you will get feedback only through like voice into your Bluetooth headsets or something. A more graceful approach would be to give like someone haptic feedback, like in the gloves or something else. My last story is create your own data that are presented at geekle.us. So when do you need your own data? We're in the mood of like magical LLM thinking available to all of us at all times, right? So what do we do with LLMs? Generative models are useful for creating synthetic data, even if they struggle with factual accuracy and reliability. Use case one is tautology generator. Train a model to generate tautologies, focusing on internal consistency rather than grounded truth. Use case two, travel image tagging. Generate image captions from personal photos using LLMs to create contextual and creative tags for journaling or curation. Synthetic data creation through LLMs use LLMs to bootstrap datasets for tasks like tautology generation or image captioning without relying on factual correctness. I use techniques like distillation and fine tuning to help adapt LLMs to specialized tasks by reusing generated data and tailoring models for specific use cases. The takeaway was synthetic data generation can unlock meaningful creative workflows in areas where factual accuracy is not a priority. So some examples from like the experiments that I performed. The original collab is like way clunky. Is 210 examples of tautology and do not give a reason why. Because usually what happens when you're like talking to something that was designed to be a chatbot is they give you a lot of reasons back as to why the sentence that they have is a tautology. A bunch of these sentences are actually not real tautologies, but some of them are. And the trick that I found out to like verify if the sentences are actually tautologies is to give them back to another LLM to verify whether they are actually. But some of the good examples I really like are the second one, water is wet. That's a tautology. Fire is hot. That's a tautology. And generate 10 examples of metaphors and do not give reasons why. Her voice was a CD that played on repeats in my mind. And basically, I gave her the prompt to use the word CD. That's straight up crazy, right? Can you think of a lot of metaphors using the word CD? Her voice was a CD. His anger was a CD that scratched and scuffed the surface of our relationship. My job was a CD that skipped and glitched, making it harder to enjoy the music. So there, this is synthetic data. It's really cool data. I just want to say it's really cool data. Thank you. This was all. For an example of caption generation using images, that was something that I used in my travel blog. Thank you so much. The slides are courtesy of Slides Carnival. Thank you so much. Have a good day. Bye.